In the last video, we introduced a new method to tackle partial fraction setups, and we called that the cover-up method. And in this video, I want to continue building on that just a little bit, but mainly talk about a new type of partial fraction setup and how we can deal with that. And what you can see here, this might look a little new to you. We see that we have this linear factor in our numerator, but then looking at our denominator, we have this product of two factors. One of them is linear, so we've seen that before, that's x. But then we have this new thing that maybe you haven't seen before. We have this quadratic factor, and it can no longer be factored. So we have that here, and we're going to figure out how we can deal with that, how we can set up partial fractions. And I guess maybe it would be a good question to ask, why do we even want to set up partial fractions with this? What is this telling us? That, oh, we need to use partial fractions. And there's two things in particular. Number one, you can see that all the factors here, we can no longer factor out anymore. We can't reduce them. We can't try to cancel anything. So that's one indicator. And then a second indicator is looking at the degree of our numerator versus the degree of our denominator. You can see in our denominator, we have a degree of 3. And then a numerator, we have a degree of 1. So that tells us when our denominator has a greater degree than our numerator, we can't do any sort of long division to simplify things. So that is another indicator. Now, with that being established, let's pull out this integrand and start writing out a partial fraction setup for it. So there's our integrand, and we're just going to write this out. We know how to deal with x. We've already seen that a bunch so far, so that's going to be a over x. That's not something new. But now, how do we deal with x squared plus 9? And the general rule of thumb here, I'll just state it out. The general rule of thumb when we have x squared plus 9 in this denominator here, our numerator needs to have 1 degree less. So it's going to be the following. We're going to have bx plus c in our numerator. And this right here is the partial fraction setup. And now all we need to do is solve for a, b, and c. So let's do that. And the question to ask is, we saw this cool method in the last video, cover up, helped us move through a little quicker. Can we use cover up on any of these? Can we use cover up to find a, b, or c? And the answer is yes, we can use cover up, but not on everything. We can use cover up to find only a here, only a. So let's use cover up to find a. We're going to find a first. All right. And using cover up, we need to let x be equal to 0. Let x be equal to 0. And if you haven't seen the last video, I'd encourage you to go back. We're not dividing by 0 here, and you'd see that in the last video. So using cover up, we let x be equal to 0, and we get the following. We have a is equal to, and then evaluating this left-hand side at x is equal to 0, and remember this x cancels. So we have 3 times 0 plus 4, and then over, we have 0 squared plus 9 in this denominator, and it looks like we get a is equal to 4/9. So there's a, we got one down, and now we have to find b and c. And we can't use cover up to find b and c here. There's nothing we could do to get this quadratic term to go to 0. So no cover up with b and c. So what do? And maybe you've seen this in previous math classes, but essentially all we're going to do is clear out this denominator on this left-hand side. So let's clear out this denominator. Let's multiply both sides by x squared plus 9 times x. All right, this side 2. X squared plus 9 times x. All right. And this is going to cancel. We've cleared the denominator now. And then distributing this to both of our terms here, we get what? We get on this left-hand side, we have 3x plus 4. And then right-hand side, these x's are going to cancel on a. So we're left with a. We're left with a. And then times x squared plus 9. X squared plus 9. And then bx plus c, so we have plus bx plus c, plus bx plus c, and then x squared plus 9 is going to cancel, and we're left with just x, so times x. This is what we have from clearing that denominator, and let's continue to expand these out. So we have 3x plus 4 on this left-hand side, and then the right-hand side we have, I'll just leave it all in white now, so we have ax squared plus 9a, okay, and then plus bx squared plus cx. That's what we have from expanding everything out. And now what we want to do, again, we're after b and c here. And in order to find those, we are going to construct equations that relate the coefficients on the various degree terms. And that might sound a little foreign, but it's simpler than how I'm explaining it. So if we were to write this out, we were to say 0x squared plus 3x plus 4, all we're going to do is grab the coefficients on the various degree terms and construct some equations. So looking at our second degree term here, on this left-hand side, we have a 0. And then on this right-hand side, we have an a and a b. Those are all coefficients on our second degree terms. So we just write down an equation. We have 0 is equal to a plus b. And we already know what a is, so we can solve for b. So we have 0 is equal to 4/9 plus b. And we find that b is equal to negative 4/9. So we found b. Yay. And lastly, we're going to look for c. And same process here. We look at on this right-hand side, we see that c is on this first degree term here. We have a c, and we have nothing else that associates with a first degree term. And then look at this left-hand side, we just have a 3. So we get to write this down. This guy came out pretty easy. This is c is equal to 3. And now we have a, b, and c. So all we need to do, we've solved our partial fraction setup. We can just come up here and rewrite our integral. Let's rewrite our integral. So we have the indefinite integral now. Under our partial fraction setup, we have 4/9, that's a, over x, and then we have plus, and then I'm going to split this up. So I'm going to have bx over x squared plus 9. So we found b to be negative 4/9, so times x, so that's bx over x squared plus 9. And then I'm going to have this other term here as well. So we have 3. We're going to have c is 3. So we have 3 over x squared plus 9. All right. So that's what we have for our integral, our integrand, and we're integrating all of this with respect to x. There is our indefinite integral under our partial fraction setup. And really now, to solve this, these are 3 easy integrals. You can split these up into 3 integrals here and integrate everything with respect to x. And you would see that these integrals are pretty easy to solve. This first one here, you could just write down the answer. It's 4/9 times the natural log of the absolute value of x. This guy right here, you would probably want to use some u substitution, it looks like. And then this last integral, this last indefinite integral, probably is the hardest one. This is a trigonometric substitution. And you'd probably want to use the fact, it looks like tangent squared plus 1 is equal to secant squared. So you'd want to use that trigonometric identity to solve. But you already have the tools in order to solve all of these integrals. I really just wanted to show you, how do we deal with these irreducible quadratic factors in our denominator? What does a partial fraction setup look like for those? And we saw that the numerator needs to have 1 degree less. And you'll see another partial fraction setup in the next video.